welcome to Virtual Protocol Podcast.
Imagine walking into your office in, the year 2026. Your phone doesn't just buzz with a regular calendar reminder.
Right, it's not just a ping on a screen anymore.
Yeah, exactly. Instead, it seamlessly coordinates with a humanoid robot in the corner of the room to hand you your coffee precisely as you walk in.
All while simultaneously parsing complex quantum data.
Right, parsing data to reorganize your entire company's supply chain, and doing all of this without ever actually connecting to a centralized cloud.
It sounds completely wild, right? Like a scene pulled straight from a sci-fi novel. But the underlying mechanics for that exact scenario are, well, they're actively being built right now.
Yeah, which is crazy to think about.
I mean, we are really moving away from technology as this flat, isolated tool. We're moving toward an interactive physical intelligence.
And that is exactly what makes today's deep dive so incredibly urgent for you listening right now. Because, if you thought the AI revolution was just about typing a prompt into a browser to generate a polite cover letter or a colorful image, you really need to recalibrate.
Absolutely. The landscape is shifting dramatically.
Today, we are decoding a massive, highly detailed roadmap. It's laid out by IBM technology experts Martin and Aaron Bauman, and they've pinpointed 8 converging AI trends that will basically hit critical mass by 2026.
And the overarching theme of all their research is that artificial intelligence is finally escaping the screen.
Escaping the screen. I love that phrasing.
Yeah, I mean, we are looking at a fundamental rewrite of how digital logic interacts with the physical world, how it's governed, and even the actual silicon it runs on.
So our mission today is to cut through all the heavy tech jargon in these sources and figure out the how and the why behind these shifts.
Yeah.
We're going to explore how this technology will fundamentally alter the way you work, how you move through the physical world, and how you interact with reality itself.
It's a huge scope.
It really is. So let's start with where we spend most of our day, right? Our digital workflows. According to the IBM team, 2025 was considered the year of the agent.
Right, where we got used to solo bots writing code or drafting emails for us.
Exactly. But 2026 introduces something called multi-agent orchestration. Okay, let's unpack this, because it sounds to me like we're watching AI evolve from a scrappy solo freelance contractor into a full-blown corporate department.
That is a really helpful visualization. But let's reframe that just a little bit. It's not just about adding more bots to the payroll, so to speak.
Okay, what is it about them?
It's about breaking down the actual architecture of problem solving. See, a single AI model, no matter how massive it is, acts like a black box.
Right, you put something in, you get something out, but you have no idea what happened in the middle.
Precisely. You give it a complex prompt, and it spits out this massive output. But if it hallucinates or makes a logic error on, say, step 3 of a 50-step process, the entire final output is corrupted.
And you have absolutely no idea where it went wrong.
Exactly. Multi-agent orchestration changes the architecture entirely.
So instead of one giant brain trying to do everything all at once, you divide the labor.
Yes, exactly. You have a planner agent, and its sole function isn't even to solve the problem.
Wait, really? It doesn't solve it?
Nope. It just looks at your broad goal and decomposes it into a logical sequence of bite-sized tasks. Then it routes those specific tasks to specialized worker agents.
Oh, wow. Okay, so it's literal delegation.
Totally. One worker might be heavily optimized just for calling external APIs, while another is, strictly tuned for writing Python scripts.
And the source mentions a critic agent as well, right? Operating under a master orchestrator. But wait, I have to push back a little here.
Go for it.
If the critic agent evaluating the work is also an AI, aren't we essentially just trusting machines to grade their own homework? I mean, that feels like a recipe for a very confident, very wrong echo chamber.
What's fascinating here is that the critic agent is actually what dismantles the echo chamber.
How so?
Because the critic agent operates on a completely different system prompt and often an entirely different underlying model than the worker agent.
Oh, interesting. So they aren't clones of each other.
Right. Its objective function is adversarial. It is literally rewarded for finding flaws, security vulnerabilities, or logic gaps in the worker's output.
Ah, okay. So they're almost fighting each other to get the best result.
Exactly. By breaking the massive black box into these discrete, adversarial, and highly visible steps, you are forcing the AI to show its work at every single stage.
Which makes it verifiable. You aren't just staring at a final answer and hoping it's right. You are looking at a fully auditable trail of decisions.
And that transparency is the key to the next concept they highlight, which is the digital labor workforce.
Right, because these agents can now parse multimodal inputs, meaning they ingest text, audio, and images all at the same time.
Yep, they aren't just drafting documents anymore. They're executing integrated workflows directly into downstream systems.
Like updating financial ledgers or triggering emails.
Exactly, and altering databases autonomously based on those multimodal inputs.
But if they're making actual business decisions autonomously, that sounds like humans are getting entirely boxed out of the process. Like, what do
Yeah.
we even do?
Yeah. The IBM roadmap actually argues the exact opposite of that. They heavily emphasize the absolute necessity of human-in-the-loop AI.
Human in the loop. Okay, so we aren't obsolete just yet.
Not at all. Because the workflow is now transparent and broken into discrete steps, humans transition away from doing the manual repetitive labor.
Right. The bots do the heavy lifting.
Exactly. Instead, you provide strategic oversight. You step into the workflow at specific, verifiable checkpoints to approve or correct the critic agent's findings.
Okay, so it transforms the human from a laborer into, like, a strategic director.
Precisely. It creates a massive force multiplier for your own capability.
Okay, so digitally, we've got this highly efficient, self-correcting team of AI agents running our workflows. But obviously, we don't live our lives entirely inside databases and spreadsheets.
Sadly, no, we don't.
We live in a physical, three-dimensional world with gravity and friction and messy rooms, and that implies a massive shift. Because getting a digital agent to understand a spreadsheet is very different from getting it to, say, fold laundry.
Oh, it's an entirely different dimension of computing. Up to now, the frontier has been large language models mastering text or diffusion models mastering pixels.
Right. Diffusion models basically learning how to reverse static noise into a coherent 2D image.
Exactly. But neither of those architectures inherently understands that if you push a glass off a table, it shatters.
They don't know physics.
Right. They just know patterns in data. So moving into 2026, the focus shifts aggressively to physical AI.
And the sources point out that previously, getting a robot to navigate a room meant a human engineer had to sit down and program incredibly explicit, rigid rules.
Hard-coded logic.
Yeah, like if the ultrasonic sensor detects an obstacle 2 feet ahead, reduce speed by 50% and turn left.
And that approach is just inherently brittle.
Because the real world is unpredictable.
Exactly. The moment the robot encounters a scenario outside of those explicitly coded if-then statements, like a glass table, that the sensor doesn't bounce off of properly, the whole system fails.
Oh, right, because it can't see the glass, so it just crashes right into it.
Yes. So physical AI completely abandons that old paradigm. Engineers are no longer hand-coding rules. Instead, they are training what the roadmap calls world foundation models.
World foundation models. Okay, but how exactly does a model learn about the world if you aren't giving it the rules?
Through massive, hyper-realistic digital simulations.
Like a video game engine.
Pretty much. You build a physics engine that perfectly replicates the laws of thermodynamics, gravity, material resistance, all of that.
Okay.
Then you drop the AI model into that simulation millions of times. It learns through trial and error how the physical world actually operates.
Wow. So it learns the delicate tactile feedback required to grasp a fragile object, like an egg, without crushing it.
Exactly. It isn't following a script. It is constantly predicting the physical outcome of its next movement based on what it learned in the simulation.
That is wild. And the sources state that by 2026, these world foundation models are what finally take humanoid robots out of controlled research labs and scale them into actual commercial production environments.
It's the missing piece of the puzzle for robotics, really.
Which brings us to a concept in the source material that genuinely made me pause. They talk about social computing.
Ah, yes. The shared fabric.
Right. They describe a scenario where these humanoid robots, our digital agents, and human beings are all connected in a shared AI fabric. Information flows seamlessly between all entities. The text calls the outcome an empathetic emergent network or real-world swarm computing.
The terminology is definitely dense, but the implications for how we interact with environments are profound.
Whoa, okay, I have to interrupt because empathetic emergent network and swarm computing sound incredibly academic and, frankly, deeply intimidating.
I get that. It evokes some strong imagery.
Yeah, like we're going from a robot that learns not to crush an egg to a swarm.
Yeah.
What does that actually look like in my living room? Is this a sci-fi hive mind scenario?
It's a really natural reaction to the word swarm, but let's strip away the sci-fi connotations for a second.
Okay, please do.
Swarm computing, in this specific engineering context, simply refers to seamless context exchange without latency.
Context exchange. So devices talking to each other.
Exactly. Think about how much context is lost between the various devices you use today. You have to explicitly tell your phone what you want, then you sit down at your laptop and have to establish your intent all over again.
Right, they operate in totally isolated silos. My laptop doesn't know what I was just doing on my phone.
Exactly. In a social computing fabric, the swarm simply means that the digital agents and physical robots in your environment continuously share a unified understanding of state and intent.
So they're all on the exact same page.
Yes. If you tell your digital planner agent to prepare you for an emergency flight, that context is instantly exchanged with the physical robot in your home.
Oh, wow.
And that robot immediately begins packing a bag based on the weather at your destination. It's called empathetic, not because the machine feels human emotion.
Right, it doesn't actually care about me.
Right. But it is highly sensitive and responsive to your immediate contextual needs without requiring explicit step-by-step programming for every single action.
Okay, so if we have AI swarming our social spaces, seamlessly sharing our personal context and physically operating robots in our homes and offices, the immediate glaring question is accountability.
Oh,
Like, who is liable when a swarm network makes a mistake or violates privacy? We urgently need rules to govern this.
And that regulatory framework is arriving right on schedule. By mid-2026, the European Union's AI Act becomes fully applicable.
The EU AI Act. The experts in the IBM video describe it perfectly. They say it is essentially GDPR, but for artificial intelligence.
That's the best way to think about it.
And GDPR completely rewired how every website on Earth handles cookies and user tracking. It sounds like the EU AI Act is poised to set a similar global template for AI governance.
It definitely will. The core mandate here is that high-risk AI systems must be auditable and traceable.
But how do you actually audit a neural network that has trained on literally billions of data points? That sounds impossible.
It requires an absolute overhaul in how models are built from day one. The Act demands immense technical documentation, proving exactly how models were tested for bias.
Okay.
Demands transparency. Like if a human is interacting with a machine or reading synthetic text, it must be clearly labeled as artificial.
No more faking it.
Right.
Right.
But the most technically demanding requirement is data lineage.
Data lineage. What does that mean in practice?
Builders have to mathematically prove the origins of their training data. They have to definitively show that they respected copyright opt-outs.
That sounds computationally exhausting.
It is, very much so.
To constantly track and verify the lineage of every piece of data in real time while simultaneously running an empathetic swarm network? I mean, you can't just run that on a standard laptop.
You can't. And you also can't rely entirely on massive centralized data centers to do it either.
Why?
Because if a humanoid robot is catching a falling object in your living room, it cannot afford the round-trip latency of sending that data to a server across the country and waiting for a response.
Oh, right, because by the time the server responds, the object has already hit the floor.
Exactly. The physics of the real world demands zero latency.
Which naturally leads us to the next massive shift: reasoning at the edge. Edge computing meaning processing data locally, right on the device itself.
Right.
Last year, the big news was that small models with just a few billion parameters could fit on your phone. But in 2026, the roadmap says these tiny local models are learning to truly think.
And to understand why this is such a huge breakthrough, we need to look at how the massive cutting-edge models currently operate in the cloud.
Okay, babe on me.
The absolute best models today utilize a mechanism called inference time compute.
Meaning they think before they speak.
Yes, older models operated like an advanced autocomplete, right?
Correct.
They just calculated the statistical probability of the next word.
Just guessing what comes next.
Exactly. Inference time compute pauses that process. It forces the model to generate a hidden chain of logic, breaking a complex problem down step by step.
Oh, so it's evaluating multiple pathways internally.
Yes, and correcting itself before ever outputting a final answer.
It's like a human sketching out a math problem on scratch paper before writing down the final solution on the test.
That's a perfect analogy. It makes the models incredibly accurate. But that scratch paper process requires absolutely massive amounts of computing power running in giant server farms.
So how do you get that onto a phone?
The breakthrough for 2026 is a technique called distillation. Researchers are taking the vast, high-quality logic chains generated by the massive models and using that specifically curated data to train much smaller models.
Oh, wow. So they're teaching the small model the actual logic of how to solve the problem rather than forcing it to memorize the entire internet.
That's exactly the mechanism. And because these distilled models are so compact, They don't need a data center.
They can physically reside on the silicon of your phone or your laptop?
Yep. Your data never leaves your device, providing absolute privacy.
Mhm.
And there is zero network latency, allowing for real-time physical AI applications.
Okay, here's where it gets really interesting.
Uh-oh.
Well, we just talked about the EU AI Act demanding strict auditing and data lineage, right?
Right.
But if your phone is running a deeply capable reasoning AI completely offline, how does a regulatory body govern a model that lives entirely in your pocket and never talks to a centralized server? I mean, how do you audit a closed loop?
This raises an important question, and it really exposes the inherent tension between absolute data privacy and regulatory oversight.
Because you can't have both perfectly.
Exactly. The reality of 2026 is that auditing cannot happen at the point of use.
Okay, so when does it happen?
Verifying the AI before it ever gets pushed down to your local device will become the new absolute gold standard for safety.
Oh, so the audit happens at the factory during the distillation process.
Precisely. Regulators will verify that the foundational logic the small model learned was built on ethically sourced, copyright-respected data before you ever even download that brain to your phone.
Okay, so the factory is regulated even if the car is driven completely off the grid. That makes sense.
Right.
But to power all of this, these hyper-fast local reasoning models, these verifiable frameworks, and these multi-agent corporate teams in the cloud, the actual physical hardware of our world has to change.
It absolutely has to. Traditional silicon computer chips simply aren't going to cut it anymore.
They just don't have the juice.
Yeah.
And that brings us to the ultimate engine driving this entire 2026 roadmap.
Yeah.
It's a literal mutation in hardware and infrastructure.
Specifically what the roadmap calls amorphous hybrid computing and quantum utility.
Amorphous hybrid computing. The source describes this as a fluid computing backbone that dynamically blends different AI model architectures and cloud infrastructure.
Right.
For instance, it notes that AI is shifting beyond just the pure transformer designs we rely on today. It's integrating with things called state space models.
And the mechanism here is so crucial. The AI boom of the last few years was entirely built on transformers.
Right. The T in ChatGPT.
Exactly. Transformers are incredibly powerful because of a mechanism called attention. They look at every single word in a document simultaneously to understand the broad context.
Okay, that sounds good. Why is that a problem?
It creates a massive bottleneck. If you feed a transformer a massive book, the computing memory required scales quadratically. It gets too heavy too fast.
Oh, I see. It just hobs all the resources.
Exactly. State space models, on the other hand, operate differently. They process information continuously, selectively compressing and remembering what's important over time.
So it's not looking at everything all at once.
Right. And because of that, it scales linearly. It requires far less memory for continuous streams of data, like audio or real-time physical sensor data.
So amorphous computing is about combining the deep analytical power of transformers with the fast, continuous processing of state space models. But to run these hybrid models, the physical chips in the cloud are radically differentiating. We aren't just using standard CPUs and GPUs anymore. The infrastructure will automatically map workloads across specialized chips, including neuromorphic chips.
Neuromorphic engineering is just a fascinating departure from traditional computing.
Neuromorphic, meaning brain-like.
Exactly.
Yeah.
Standard chips use the von Neumann architecture, moving binary ones and zeros back and forth between a processor and memory.
Right.
Neuromorphic chips physically emulate the structure of the human brain. They use artificial spikes of electricity that mimic neural synapses, processing and storing information in the exact same physical location.
Oh, wow. So it eliminates that back and forth travel time.
Right, which makes them exponentially more energy efficient for the kind of continuous pattern recognition required by physical AI.
That is incredible. And the roadmap doesn't stop at brain chips. It also highlights trend number 8. Quantum utility everywhere.
This is a huge one.
For decades, quantum computing was a theoretical marvel, but it was confined to, deep freeze research labs.
True. But 2026 marks the era where quantum computing reliably starts solving real-world problems better, faster, or just more efficiently than our traditional classical computers.
So the concept of quantum utility means it is finally useful for mainstream business. It's moving beyond just a science experiment.
Exactly. It tackles incredibly complex optimization and simulation tasks that classical computers would need, well, literally thousands of years to calculate.
So what does this all mean? Let me try to visualize this amorphous hybrid setup.
I'd love to hear it.
Okay, if a standard CPU is a chef who has to taste one single recipe at a time to find the best one,
Okay.
A quantum processor utilizes superposition, meaning it acts like a chef who can taste millions of different recipes simultaneously to instantly find the perfect flavor profile.
I like that.
And amorphous computing is essentially the master kitchen director standing in the middle who automatically knows exactly which ingredient goes to the CPU, which goes to the neuromorphic chip, and which complex simulation gets routed to the quantum chef, all in milliseconds.
If we connect this to the bigger picture, that analogy perfectly captures why 2026 is a tipping point.
It's all coming together.
Exactly. Quantum computing, neuromorphic chips, edge reasoning, none of these exist in isolation anymore. They are being woven into a fluid, automated backbone.
So you, as the end user, will never have to choose which chip to use.
Right. The system orchestrates the hardware just as seamlessly as it orchestrates the software agents.
It is truly staggering to step back and look at this complete picture. I mean, we started this deep dive looking at solo AI bots, and we've decoded how they are evolving into highly orchestrated, verifiable corporate teams.
Yep.
We've explored the mechanisms of how World Foundation models use physics engines to bring humanoid robots out of the lab, creating these shared, context-aware networks with us in the physical world.
And we've unpacked how the EU AI Act will force a new era of data lineage and accountability, and how the massive compute required to reason through logic is being distilled down to run locally on your phone at the edge.
All while the global cloud infrastructure mutates into an amorphous, fluid mix of quantum processors and brain-emulating chips.
It's a lot to take in.
It is a whole lot. The most important takeaway for you listening right now is that this is not speculative fiction. These are the concrete engineering frameworks and infrastructural realities actively being deployed today.
Absolutely.
This is the exact technology that will reshape your career, your privacy, and your daily life by 2026.
And as we navigate that transition, I really want to leave you with a final thought to
Yeah,
ponder.
hear it.
Imagine a scenario where one of those highly efficient brain-emulating neuromorphic chips is sitting inside your personal, completely offline device.
Okay.
On that chip runs a distilled, reasoning multi-agent swarm
Yeah.
dedicated entirely to your life.
Just my own personal swarm.
Exactly. If that swarm fundamentally understands the physics of your world, seamlessly intuits your context without being prompted, and perfectly predicts your needs while completely disconnected from the internet,
What?
at what point does it stop being a discrete tool you use and start functioning as an actual physical extension of your own mind?
Oh, man. That is an incredibly wild thought to leave on.
It really blurs the lines.
It does. The boundary between the user and the utility is about to get very blurry. Thank you for joining us on this deep dive into the AI landscape of 2026.
It's been a great conversation.
It really has. As technology transitions out from behind the glass and into our physical reality, keep questioning the systems around you, keep learning, and as always, keep exploring.